All right, guys, this is the last video I'm going to make for graphing inverse functions. There are more examples on the back of this worksheet, but you can just access my answer key in class. So for example D here, I've already done my work on how to find the inverse. So let's walk through that one more time. First, I changed the f of x notation to y equals. Then I switched where x and y are in the equation. And then I start solving for y. The first thing I did was get rid of this plus 12 by subtracting 12 from both sides. Then I got rid of a negative 3/4 times y by multiplying by its reciprocal, negative 4/3. So now I've got negative 4/3 times all of x minus 12. I distributed the negative 4 out and then divided everything by 3. There's lots of ways you could get to this final result. So my inverse function is negative 4/3 x plus 16, and I like it in this notation because it looks like a linear function. It looks like y equals mx plus b, and I'm really good at graphing that. Now, the problem with both of these functions, if I was to graph it by hand, is that my graph is not big enough. The original function's y-intercept goes up to positive 12, and the inverse function's y-intercept goes up to positive 16, but my graph only goes up to 10. So I am going to take this over to Desmos. And I have pre-typed them in, so it makes this video go a little faster. So here's my function that was the original, negative 3/4x plus 12. That's the red function. And then the blue function is the inverse, negative 4/3x plus 16. You guys, I know this is an accurate inverse because, again, these functions are a reflection over the line y equals x, which is this green function running through the middle. If I need to take some of these points over to my sheet of graph paper, okay, I can use some of the points that Desmos gives me, but what you're going to see here is that they are all too large for our 10 by 10 piece of graph paper. So you're going to have to come down the line and hover and let the function, let Desmos give you some points along the function. So I'm going to try to find a good point here. Let's see what negative 1 is. Well, that's higher than 10, so that's not going to be a good point. Let's try, oh, there's one. Okay, I found one at 4, 9. So I'm going to plot the point 4, 9 over 4 up 9. Okay, and then I'm going to keep on coming down the function here. See if I find anything else. Let's see. 5 and 8.25. 5, comma 8.25. Well, those are so close together, I don't know if they're helpful. Let me keep on going down the graph here. How about 11, comma 3.75? Well, 11's out too far. I got to come back up. This is a small graph. All right, 10, comma 4.5. 10, comma 4.5. Okay, so I'm just jotting down those 3 points. Let me switch my screen again. And I've plotted them. 4, comma 9, 5, comma 8.25, and 10, comma 4.5. Those are pretty good points that give me a good view of this graph as it comes down. Remember, when you are drawing an inverse, all you really need to do is reverse the points. So 4, 9 turns into 9, 4. 5, comma 825 turns into 8.25, comma 5. And 10, comma 4.5 turns into 4.5, comma 10. So now I can plot those points. Over 9, up 4. Over 8.25, up 5. Over 4.5, up 10. Just remember, the graph you're making here is a sketch. It doesn't have to be perfect. Okay, and you could use any points that you hovered over. I just tried to pick ones that were easy to graph. And here's the check. If you draw in your y equals x, which is a slope of 1 going through the origin, does it create a line of symmetry? Are those two functions a reflection of each other? If the answer is yes, then you have done a great job finding the inverse function and graphing it. All right, guys, I hope these videos have helped you prepare. If you need any help, come see me, and happy studying.